The Radio Wammo Breakfast.
Live from the New Scientist Labs, Janine Young, newscientist.com.
With the latest in new science from all around the world, joining us in Melbourne City, Janine Young. Good morning, Janine.
Good morning.
Good morning to you. Now, there's a question that I've been sort of pondering over the last week or so. You know, really been thinking about it for a wee while now. Why are so many sexual appendages asymmetrical?
You have not been thinking about that.
I have, Janine. Wondering. Sitting here thinking.
You think about some interesting things then, my friend, because we're actually talking about it this week.
Oh, well, there you go. Okay, all right. Well,
even the humble human male, we would know if you've looked at statues even. And this is true. There have been anthropologists that have gone through and looked at the number of naked statues, including David in Florence, as to whether or not they are symmetrically packed, shall we say, and they've found that they're not. Even tailors know the difference. They often will ask whether or not sir dresses to the left or to the right.
Yes, that's sir, yes.
That's a very important thing when you're having a tailored suit, apparently. I wouldn't know, but my other half tells me that a really good tailor will ask whether or not sir dresses to the left or the right. However, that's nothing compared to the world of nature. Now, we've found this before when it comes to other sexual strategies and the like, but this one is actually talking about the apparatus, talking about the bits, shall we say. And I'm going to try and keep a straight face through this because it's hard, I'll be honest. We know that insects in particular tend to have genitalia that are more like Swiss Army knives. They've got a whole bunch of plates and levers, and there's a lot going on there, I'll put it that way. Camels, and here's one I didn't know, have a two-pronged penis, and it runs in different directions. Llamas are just the same. Beetles, fish, ducks. The humble pig, for example, has a corkscrew-shaped penis.
Huh.
Yes, and I found out yesterday that apparently the female, if it is inseminated naturally or with a corkscrew-shaped apparatus that is similar to the boar's, actually takes longer to copulate and uses more sperm than if you use just an ordinary straight introducer, shall we say.
Yeah.
I'm being so good here. Please note that. This is just bizarre stuff.
Well, but I guess that makes sense, you know. The male, female of the species, they're made to fit together the right way.
And that's the thing. A lot of this was all considered very strange for quite a long time because it was sort of thought, well, why would you possibly need appendages that don't just naturally fit together and are straight? Why would you need any kind of alternative? Well, there's a few reasons as to why that might be. Certainly in insects, it comes down to a lot of things like sexual conflict. A lot of female insects don't want to be mounted and inseminated by the male. They don't want that particular individual, or indeed anywhere near them. So apparently originally the mating position for a lot of insects was actually female on top. And that's changed over evolutionary time. Some of the mayflies and the like still do it old school, if you like.
Yeah.
But they've had to change their strategy with a very complicated penis that's able to then be able to twist around with their abdomen to be able to get to the spot where the female is able to accept what it is they have to give.
Yeah.
Pardon me.
Oh, bless.
Quietly dying.
Yeah.
Yeah, just die quietly, why don't I? But it can also be about introducing the maximum amount of sperm. As I said with the pig, if you have the correct shape, then it can be also a response in conjunction with the cues that are given during mating as to how long a female will allow a male to stay where he is and introduce what it is he wants to. So there's a number of different reasons why this might happen, but sometimes it's a practical thing as well. Daddy longlegs, the spiders, apparently, aside from just one species, are symmetrical. Their body patterns mean that they are exactly the same on the left as they are on the right. However, there is one...
But are you going to tell me that a daddy longlegs has an appendage?
Oh, yes.
What?
Oh, spiders have the most amazing sexual apparatus.
Wow.
The males always have something out their front called a pedipalp. In fact, they've got 2 of them. And they've found in the daddy longlegs of this particular species that the right-hand one is a lot larger than the left, and they could never really work out why.
Is one a backup, or for the other, if the other fails? Or...
Well, actually, it's all to do with the fact about how the female is packed. On the inside, she's actually got all of her reproductive systems on the right-hand side, which means that the male wants to try and direct everything he can to that side in order to be able to have a successful outcome from their copulation. And so that's why his pedipalp on the right-hand side is a lot larger than it is on the left.
So are they saying that maybe, I'm speculating here, but maybe she was all packed on the left-hand side in the past, and over time the male spider's gotten used to, well, no, now she's gone to the right, so the one on the left for him is shrunk. Would that be how it would work?
It's that sort of thing, yes. So originally, she would likely have been symmetrical, like every other daddy long-legged spider out there. You will never look at daddy long-legged spiders the same.
No, I certainly don't. You look at the spider and you go, what? No. Appendage?
Yes.
More packed on the right than the left? Yes. Never. Get out of town.
There's Madam Dress to the right, yes. But yeah, in this case, it's all to do with the fact that over time, and we're talking, millions of years here, she would have shifted from being symmetrical like every other type of daddy long-legged spider to having herself packed on the right-hand side. Why? Well, that's a completely separate question. We don't actually know. But clearly you have this conflict between males and females. A lot of the time, females don't necessarily want to be inseminated. They don't actually want the attention of a male, but they get it anyway because that's part of what life is, We exist to reproduce. That's fundamentally what evolutionary drivers have taken us to. So the fact that over time there's been these subtle shifts, and whatever made that happen in the first place, we don't know. But these subtle shifts over time mean that whenever a female changes, a male is going to try and keep up, and they're going to change subtly and find new strategies to make sure that they can still reproduce.
Really interesting. No doubt in the New Scientist article there's a bunch of diagrams to demonstrate some of this.
No diagrams.
No diagrams.
Only a picture of camels copulating on page 43.
Oh, okay. Brilliant. We've talked so long about appendages that we've run out of time for the elements that have run out, but go and check out an article about the supplies that are running low for a host of obscure materials. That's in the New Scientist magazine coming out next week. Also, we'll be online as well, newscientist.com. You did very well there, Janine. Thanks very much for that.
Thank you very much. I consider myself a professional.
Janine will be back, of course, next week here on the show. Time now, though, is 24 minutes past 9. Got a track now.